the function of fx is given by, so first function fx equal to 2, whereby the limit from -2 until -1. For the second function fx equal to 0 from -1 until 1. So for the third function fx equal to x plus 1 from -1 until 2, whereby the periodic function is fx plus 4. So given that fx is a neither function, so it's already mentioned here, this one is a neither function, so we don't have to sketch the graph. Find its Fourier series expansion. So for the neither function, we need to calculate all the Fourier series coefficient, whereby you need to calculate the value for the a0, an and bn. From the periodic function here, we can determine our L, or from the highest limit here, we can determine our L. So our L is equal to 2. So from here, 2L is equal to 4, therefore L is equal to 2. For the neither function, you have to apply this formula, whereby the formula for the a0, an and bn is 1 over L, integrate from -L until L. So we need to integrate all the function. So copy down the formula. So by using this formula, we want to calculate a0, 1 over L, integrate from -L until L, fx. So we need to integrate all the function here, because our function is a neither function. So calculate the value for the a0. a0 is equal to 1 over L, whereby our L is equal to 2. So 1 over 2 integrate from -2 until 2, fx dx. So we want to integrate from -L until L, whereby -2 until 2. So from the question here, you have -2 until -1, and then 1 until 1, and then 1 until 2. So means that we have to separate our fx according to the given limit here. So for the first limit, -2 until -1, whereby fx is equal to 2. 1 over 2, make it in bracket, -2 until -1, fx is equal to 2. 2 dx plus, continue for the second limit, from -1 until 1, the fx is equal to 0. -1 until 1, 0 dx plus, continue for the third limit, from 1 until 2, the function is x plus 1. 1 until 2, x plus 1 dx. So close the bracket. So now we have to integrate first term, second term and third term. For the second term here, when we integrate 0, this one automatic will become 0. Integrate 2 will become 2x. So a0 is equal to 1 over 2 constant at the front, 2x, the limit from -2 until -1, plus, this one no need to integrate. Integrate x plus 1 will become x square over 2 plus x, the limit from 1 until 2. So now substitute the limit. 1 over 2, substitute -1 to the position of x. 2 multiply -1 will become -2. -2 minus, substitute -2 to the position of x. 2 multiply -2 will become -4. So we have finished for the first limit here, -2 minus -4, plus with, substitute for the second limit, 2 substitute to the position of x, 2 square divide with 2 plus with 2. So this one will become 4 over 2 plus 2 will become 4. Substitute the second limit 1 to the position of x. So this one will become 1 the power of 2 divided with 2 plus with 1 will become 3 over 2. Therefore minus 3 over 2. So now simplify the whole thing. 1 over 2 Negative 2 minus minus 4 will become positive 2, plus with 4 minus 3 over 2 will become 5 over 2. So 2 plus with the 5 over 2 multiply with the 1 over 2. So the answer will become 9 over 4. So this is the answer for the A0. Okay, now let us continue to calculate the value for the AN. AN is equal to 1 over L, 1 over 2, integrate from negative 2 until negative 1. So we already know that we have to separate according to the limit, so we can directly separate here. So fx is equal to 2 multiply with the cos n pi x over L. Cos n pi x over 2. Plus, integrate from negative 1 until 1. Fx is equal to 0. 0 multiply with the cos n pi x over 2 dx. Plus, integrate for the third limit from 1 until 2. 1 until 2. Fx is equal to x plus 1. Multiply with the cos n pi x over 2 dx. So close the bracket. So now we have to integrate three things. But for the 0 multiply with the cos n pi x, this one will become 0. Integrate 2 multiply with the cos, this one we apply direct integration. But for the x plus 1 multiply with the cos n pi x over 2, this one we have to apply tabular method. Integrate 2 cos. So if we integrate cos, the answer will become sine. So 2 cos n pi x over 2 will become 2 sine. AN is equal to 1 over 2 sine n pi x over 2 divide with, differentiate the argument n pi x over 2 will become n pi over 2. So close the bracket, the limit from negative 2 until negative 1. Plus with, integrate x plus 1 multiply with the cos n pi x over 2. This one we have to apply the tabular method. So in order to apply the tabular method, you must have u and dv. So u is the x plus 1, dv is cos n pi x over 2. So x plus 1 we have to differentiate until you get 0. So differentiate x will become 1. Differentiate 1 will become 0. So now differentiate 1, this one will become 0. Integrate cos n pi x, integrate cos will become positive sine. Sine n pi x over 2 divide with, differentiate the argument will become n pi over 2. Differentiate one more time, differentiate sine will become negative cos. Negative cos n pi x over 2 divide with n pi over 2, differentiate one more time, this one will become n pi over 2 the power of 2. So now apply the tabular method, cross multiply, first error positive, second error negative. So now combine the answer. So x plus 1 multiply with the sine n pi x over 2 divide with n pi over 2. So n pi over 2, this one we can change it become 2 over n pi. 2 over n pi multiply x plus 1 multiply with the sine n pi over 2. Negative negative will become positive. 1 multiply with the cos n pi x over 2 divide with n pi over 2 square. N pi over 2 square, this one can be changed, it become 4 over n pi square. 4 over n pi square multiply with the cos n pi over 2. So close the bracket, the limit from 1 until 2. So now substitute the limit. For the first bracket, this one will become 1 over 2. 2 divided with n pi over 2, this one will become 4 over n pi. Sin n pi x over 2, substitute negative 1 to the position of x. And pi multiply negative 1 divided with 2 will become negative n pi over 2. Negative n pi over 2. Minus, substitute the second limit. 2 divided with n pi over 2. 4 over n pi. Sin negative 2 to the position of x. And pi multiply negative 2 divided with negative 2. So negative 2 can be cancelled out. This one will become n pi. So close the bracket. So this one is the answer for the limit negative 1 minus limit negative 2. So now substitute for the second limit 2 and 1. Plus 2 over n pi multiply with the x plus 1. Substitute 2 to the position of x plus 1. 2 multiply 2 plus 1, this one will become 6. 6 over n pi sin n pi x. This one it should be x here. So n pi x, substitute 2 here. And pi multiply 2 divided with 2. So this one will become n pi. Plus with 4 over n pi square. Cos n pi x over 2. And pi multiply 2 divided with 2. So this one will become n pi. Cos of n pi. Minus, substitute the limit 1 to the position of x. 2 multiply 1 plus 1. This one will become 4. 4 over n pi sin n pi x over 2. Substitute 1 will become n pi over 2. Plus 4 over n pi square. Cos n pi x over 2. Substitute 1 will become n pi over 2. So close the bracket. So the whole thing, this one should be closed here. So now you have to simplify. So before this, you have learned about sin n pi is equal to 0. Sin negative n pi is also equal to 0. Cos n pi is equal to negative 1 the power of n. Cos negative n pi is also negative 1 the power of 1. So if we have sin n pi over 2 or cos n pi over 2, then no need to change. But if we have sin negative n pi over 2, this one will become negative sin n pi over 2. Whereby we move the negative inside the bracket to the front. So that's why there is no more negative inside the bracket. Negative at the front of the sign. If we have cos negative n pi over 2, this one will become cos n pi over 2. So this one we apply the concept whereby negative for the sign we bring to the front. Negative for the cos we ignore. So now for the sin negative n pi over 2, this one we will move the negative to the front. For the sin n pi, this one will become 0. For the sin n pi here, this one will become 0. For the cos n pi, this one will become negative 1 the power of n. For sin n pi over 2, this one there is nothing that we have to change. The same thing for the cos n pi over 2. So now rewrite back the answer. 1 over 2, open the bracket. Negative bring to the front. So this one will become negative 4 over n pi. sine n pi over 2. This one multiply 0, the whole thing will become 0. So the same thing, this one will become 0. So 4 over n pi over 2 multiply with the negative 1 the power of n, plus 4 over n pi over 2 multiply negative 1 the power of n, minus negative 4 multiply n pi, minus 4 over n pi sine n pi over 2, minus with the 4 over n pi square, minus 4 over n pi square cos n pi over 2. So close the bracket. So now if we have the same term, then you have to simplify. So negative 4 over n pi sine n pi over 2 will be combined with the negative 4 over n pi sine n pi over 2. So negative 4 minus 4 will become negative 8. 1 over 2. Negative 8 over n pi sine n pi over 2 minus 4. So I rearrange that cos n pi over 2 at the front, minus 4 over n pi square cos n pi over 2 plus 4 over n pi square plus 4 over n pi square, negative 1 the power of n. Constant at the front here should be multiplied inside for the whole thing. So therefore an is equal to negative 4 over n pi sine n pi over 2 minus 2 over n pi square cos n pi over 2 plus 2 over n pi square, negative 1 the power of n. So this is the final answer for the an. Okay, now let us continue to calculate the value for the bn. So bn is equal to 1 over 2 integrate from negative 2 until negative 1. So make it in bracket. So negative 2 until negative 1 for the function fx equal to 2. 2 multiply with the sine n pi x over l. Sine n pi x over 2 dx plus negative 1 until 1. Fx is equal to 0. 0 multiply with the sine n pi x over 2 dx plus integrate from 1 until 2. For the limit 1 until 2, fx is equal to x plus 1. X plus 1 multiply with the sine n pi x over 2 dx. So close the bracket. So the same thing, 0 multiply anything, this one automatic will become 0. So we have to integrate 2 multiply with the sine by using direct integration. X plus 1 multiply with the sine n pi x over 2 by using tabular method. So this one direct, this one by using tabular method. Integrate 2 sine n pi x over 2. Integrate positive sign will become negative cos. 1 over 2 negative 2 cos n pi x over 2 divide with, differentiate the argument will become n pi over 2. So close the bracket, the limit from negative 2 until negative 1 plus with the answer for the tabular method. You must have u, you must have dv. U is the x plus 1, dv is sine n pi x over 2. So differentiate x plus 1 will become 1, differentiate 1 will become 0. Differentiate sine n pi x over 2, differentiate positive sign will become negative cos. Negative cos n pi x over 2 divide with n pi over 2. Differentiate negative cos, differentiate negative cos will become negative sine. Negative sine n pi x over 2 divide with n pi over 2 the power of 2. So combine the answer, the first error with the positive sign, the second error with the negative sign. Positive and negative will become negative. X plus 1 multiply with the cos n pi x over 2 divide with n pi over 2. So n pi over 2 can be written as 2 over n pi. So negative 2 over n pi multiply x plus 1 multiply with the cos n pi x over 2. Negative and negative will become positive of n pi over 2 the power of 2 will become 4 over n pi square. 4 over n pi square sin n pi x over 2. So close the bracket, the limit from 1 until 2. So close the whole bracket for the whole thing. So now substitute the limit. 1 over 2 n pi over 2 at the bottom side multiply with the 2 here can be written as negative 4 over n pi cos n pi over 2 with the negative n pi x over 2 multiply with the negative 1 will become negative n pi over 2. So substitute negative 2 to the position of x here minus, so make it in bracket, minus 4 over n pi cos negative n pi. So close the bracket. So this bracket for the substitution the first limit. So make it a different color here. So now substitute for the second limit 2 and 1. Substitute 2 to the position of x here. 2 multiply 2 plus 1 will become 6. So plus with negative 6 over n pi multiply with the cos n pi x over 2 multiply with the 2 will become n pi plus 4 over n pi square sin n pi x over 2 substitute 2 will become sin n pi. So close the bracket here, minus with, substitute the limit 1 to the position of x. 2 multiply 1 plus 1 will become 4. Negative 4 over n pi cos n pi x over 2, substitute 1 will become n pi over 2. Cos n pi over 2 plus with 4 over n pi square sin n pi x over 2, substitute 1 will become sin n pi over 2 plus 4 over n pi square sin n pi over 2. So close the bracket. So this one for the second limit 1 and 2. So now simplify. Cos negative n pi over 2. Cos negative n pi over 2 will become cos n pi. Sin negative n pi over 2 will become negative at the front. So cos negative n pi over 2, we can ignore the negative. 1 over 2 negative 4 over n pi cos n pi over 2 minus minus will become plus 4 over n pi cos negative n pi will become negative 1 the power of n. So now continue for the second limit substitution, plus with negative 6 over n pi cos n pi. So this one will become negative 1 the power of n. So minus 6 over n pi negative 1 the power of n. 4 over n pi square multiply with the sine n pi. Sine n pi will become 0. So the whole thing will become 0. Minus with cos n pi over 2. So for the cos n pi over 2, there is nothing to change. So this one minus minus will become plus. 4 over n pi cos n pi over 2. Minus plus will become minus 4 over n pi square sine n pi over 2. There is nothing that you have to change. So sine n pi over 2. So close the big bracket. So simplify if you have the same term. 1 over 2. Negative 4 over n pi cos n pi over 2 can be simplified with this one. So negative 4 plus with 4 means that we can cancel out. 4 over n pi negative 1 the power of n minus 6 over n pi negative 1 the power of n. So positive 4 minus 6 will become negative 2 over n pi negative 1 the power of n. This one we just copy down back. Negative 4 over n pi square sine n pi over 2. So multiply constant to the inside. So therefore Bn is equal to 1 over 2 multiply negative 2 will become negative 1 over n pi negative 1 the power of n. 1 over 2 multiply negative 4 will become negative 2 over n pi square sine n pi over 2. So this is the answer for the Fourier series coefficient of Bn. After we have obtained the value for the a0, an and bn, substitute to the formula of the Fourier series expansion. So therefore fx is equal to a0 over 2, whereby a0 is equal to 9 over 4. 9 over 4 divided with 2 will become 9 over 8. Summation n equal to 1 until infinity. In the bracket an, you have to substitute all the value of this an, multiply with the cos. Make it in bracket, multiply with the cos n pi x over L, whereby our L is equal to 2. Plus with the bn, substitute all the value of the bn here. Make it in bracket, multiply with the sine n pi x over L. Sine n pi x over 2. So close the bracket for the front here. So this is the Fourier series expansion for this example. So if you can see, this example is a very long calculation because you have to integrate for 3 parts, whereby you have to integrate from negative 2 until negative 1, plus negative 1 until 1, plus 1 until 2.